Hey guys, Mike from 24 Hours Solar Power here. Today we're doing a quick video on three-phase battery backup and is it worth it? How does it work? So the thing for you as a customer at the end of the day is what do you want to run when the grid fails? So with a three-phase backup situation, if you do want everything to work, if you've got three phases, you've got three-phase ovens, you've got three-phase electric vehicle charging, you've got three-phase air conditioning, and you have a blackout, the reality is right now in Australia, if you do want blackout protection and everything to work, you will basically be paying to have 3 battery inverters on every single phase. But pretty much the only way to do it at the moment in Australia is actually have an inverter on each phase. So when the grid fails, your inverter can take power from the batteries, they all talk to each other and can supply loads to all 3 phases. So for you, the customer, at the end of the day, what that becomes is 3 times more expensive. And to handle normally the 3 inverters, you're going to want to put bigger batteries in. So it just adds up and adds up and adds up. So it really comes down to what do you want as the customer at the end of the day to have battery backup. Now, I'll show you how we normally do 3-phase battery backup. Well, battery backup single phase for a customer that has 3 phase, and which normally works out the most economical situation for everyone. And the reality is very rarely do we actually have a blackout for very long periods of time in Australia. We do do a lot of work in the Northern Rivers and at the back of Sydney and the Blue Mountains. There are some unreliable networks up the back of Queensland here where we work. And yeah, so there is some real unreliable networks where everything just fails, it's gone. But mainly for most people in Australia, it's going to be the network's pretty reliable. So with 3 phases, how we normally do it, most customers that call us will have a three-phase PV inverter already. And we put this what's called on the input. So we've got the grid here, or think about this PV inverter, the grid, and these AC loads here. They're all running from the grid side of life. So they always run from the grid. When there's a blackout, what happens is these 3 things don't work. So this PV inverter doesn't work, we can't get energy from the grid, and the AC loads, anything wired on these circuits here do not work. Line 1 here basically is actually getting powered from the Victron in this situation here. So all the energy from line 1 is actually coming from the battery inverter at the moment. So this comes from the batteries up through here. Just follow the diagram how it all comes and you'll sort of see. That's why I love using this monitoring as the example, Victron, because it's got a really good way of explaining it. So yeah, so this load here is actually not coming from batteries, it's actually coming from the grid, where this load here is actually coming from the batteries. Now, if there's grid failure, everything blacks out, doesn't work, this PV inverter doesn't work in 3 phase, your grid doesn't work in these AC loads, but you've got critical loads. In your critical loads, it's about rewiring, your circuit board, in your meter board in your house, the circuits, and what do you want on that battery backup? Now, some houses are really simple, they're really well done, the lights, the fridges, we can actually just grab some circuits and put on that battery backup. Some other houses, kitchens for example, there's been one cable run over, the oven runs off it, everything runs off that basically one circuit. So it's a bit more complicated to do, and it just comes down to the point of view from in a blackout, as a customer there's a blackout situation. If your oven, your kitchen for example, is all wired on the same circuit, just don't use that oven in a blackout situation. Just only use your lights and your fridges and stuff like that. So don't turn any heavy loads on. There are systems you can install to make everything work. It just really comes down to your budget and what it is you want as a customer. These days, really with battery backup, you can do whatever you want if you're willing to spend whatever it takes. So that's sort of the reality. And the other thing of what we do with the blackout situation is we put panels directly to batteries. Now, a lot of hybrid inverters, you'll see getting around the internet at the moment. Redback's probably one of our favourite hybrid inverter that we work with, the Redback technology. It has what's called black startability. So if the grid's failed, so overnight you've fallen asleep, the grid's failed and your batteries have gone flat, the next morning you wake up and the sun's shining and the network guys still haven't got out and pulled that tree off the line. What happens if you do not have black startability? You've got no power just like everyone else, because the solar panels cannot charge the batteries to bring the batteries up, to turn the inverter on, to give you power. So most hybrid inverters will call that black start. In this off-grid situation, we call it a PV charger. So it's an MPPT or solar regulator that goes directly to batteries. So when the sun comes out, it charges the battery directly, can bring the battery voltage back up, so this inverter can turn back on and run your loads and stuff like that. So if you do live in one of those areas where it's really unreliable grids, and when the grid does go out, it can go out for a couple of days because normally it's a tree or something over a line, I'd highly recommend getting something with a black start ability. It's going to cost more, but it's going to give you that peace of mind. And a lot of people sort of think about batteries, they never make sense financially, and they're hit and miss is the reality. It all depends how you use your energy consumption, but things what people don't take into consideration, if you do live in that unreliable grid network, you will know this, losing a fridge full of food or freezers full of food, because most people live remotely, and you could have $300 to $500 worth of meat in your freezer, grid goes down and you've just lost it. You've got to go buy a generator, run that sort of stuff. So that black start ability is really important if you do live in an area with where the network's out. And I think moving forward as a nation, it's probably something to have important to have that black start ability as well, because we are really stressing the grid out at the moment and it's getting more and more unreliable. So personally, I'd recommend having a black start ability in anything you install, unless it doesn't bother you. If there's a blackout, who cares? You're doing it for financial reasons. Install a solar inverter. For example, Huawei is an inverter which literally, Huawei put an inverter up, you put an LG Chem battery with it. Everything works great as long as the grid's available. As soon as the grid fails, that battery doesn't work. So there's a lot less moving parts in a battery like that. And it can save anywhere between $2,000 to $5,000 in installation costs. Because it just doesn't have all those moving parts required to give you that battery backup. So in a three-phase situation, battery backup, that's how we do it. We wire it, so we've got black start, panels directly to batteries. We've got your critical loads, lights, TVs and fridges and stuff working. And when the grid fails, you have three-phase PV inverter and the grid just doesn't work. So that's normally the best compromise for most customers. Most fridges, freezers and lights are all single phase, so we can do it that quite easily. And as long as the grid's working, this will, balance the grid back and spin your meter backwards. So from a net zero point of view financially, you save money. We've got a customer in Sydney, and they've installed a huge 13 kilowatt system with battery backup, three-phase PV inverter with battery backup on single phase. And because these guys use hardly any energy and how it works, they're getting about a $250 credit a month. On their bills because of the way it's been designed. And we use one of these Victron systems as well, which is a really expensive, high-end, is the reality from a backup situation. So with three phases, it's all down to you as a customer, is what you want to do, and very rarely have we ever had to back up. I don't think we've actually ever sold a three-phase battery backup situation, because the reality is in most situations with that blackout, you just want your lights and TVs and fridges to work, and you can use your barbecue to cook rather than your three-phase oven. So something to think about, guys. Really appreciate it. Any comments, please put below in the video, and like and share to your network. Have a great day.